Hello, this is section 4.2, the addition rules for probability. So first of all, we're going to talk about the mutually exclusive event. So the event is a mutually exclusive event cannot be occur at the same time. That is, the event has a no outcomes in common. So the mutually exclusive or disjoint events. So number one, events mutually exclusive. Determine if the events are mutually exclusive and which events are not. So A, roll two dice. Event A has a sum of seven, and then event B is a rolling doubles. So event A means rolling a sum of seven. So in the order pairs of the two dice to rolled, and which is 1 and 6 makes a 7, 1, 2 and 5 makes a 7, 3 and 4 makes a 7, 4, 3 makes a 7, 5 and 2 makes a 7, and 6 and 1 makes a 7. So those are the order pairs that makes a 7 as a sum. Even B is the roll doubles, which means when you have a 1, second one should be 2 because the 2 is the doubles of 1. If you have a 2, have 4 must be the 4 is the doubles of 2. If you have a 3 and then 6 the doubles of the 3, and then you got 6 1, 4 2, and then 2 1. So relationship between the number of the two dice is a doubles, right? So now you have to think about the any order pair in common in the both events, okay? So when I check the 1 6, I don't see anywhere in the event B. 2 5, I don't see any. And 3 4, I don't see any, right? So and then 4 3, 5 2, and 6 1, yeah, I don't see any. So this must be the mutually exclusive. Okay, the B, select the registered voter. The event A is a voter is a registered independent, and the event B is the voter is a registered for the Republican. So event A is the voter registered independent, and the event B is the voter that is registered Republican. So if you are independent, and then I don't think you can be a Republican. And then if you are the Republican, I don't think you can be a independent. So you have to choose the independent or Republican or the Democratic, right? So yeah, this is must be the mutually exclusive. And C, one card is drawn from the standard deck of the playing cards. Event A is a selecting a face card, and then event B is a selecting a heart. Okay, so I have a deck of the cards in here. So the selecting of face cards. So these are the face cards. These are the face cards, which is a jacks and queens and the kings, and also the selecting a heart. So these are the cards that is a heart. So as you notice, this face, sorry, this face and this face and this face card also belong into the cards of the hearts, right? So there's a in common the cards that in common, right? So this is not the case of mutually exclusive. So if the two events has a in common, and then we'll say mutually exclusive. It's not gonna be mutually exclusive. Okay. All right. Let's look at the next page. Additional rule 1. So events are mutually exclusive. We can easily get to the probability for the A or B, which is P of A plus P of B. So there's no common, so you don't need to actually subtract any. So which means this one. So when you have a Venn diagram, and this is the event A, and this is the event B, so these are the totally different things. So whatever number over of total, and then whatever number from the event B divided by total, and that'll be the sum of the probability of the A or B. So let's do the example 2. Find the probability using the addition rules. At a convention, there are 7 mathematics instructor, and there are 5 computer science instructor, and there are 3 statistic instructor, and there are 4 science instructor. None of the instructor teaches in more than one discipline, which means each of the instructor teaches only one of the subject. If an instructor is selected, find the probability of the selecting a science instructor or the statistics instructor. So we are looking for the probability of the selecting a science instructor or a statistics instructor. But none of the instructor teaching more than one discipline, right? So you can just say this one is a principal, probably of a science instructor, and then probably of the statistic instructor. So the science instructor, there's how many? There are 3, and out of total of the instructor is added up 7 plus 5 plus 3 plus 4. I think we got 19. So there are 19, and then there are the no science instructor is a 4. Sorry about that. It's my mistake. And then there are 3 statistics instructor out of 19. So you got 7 over 19. So that's the probability. And then you can change the decimal. So if you 7 divide by 19, you get about 0.3684. So when we are working for the probability in decimal, we try to get the 4 decimal places, okay? Now, the additional rules, which is the case of that the events are not the mutually exclusive. So when when 2 events A and B are not mutually exclusive, the probability that A or B will occur is the P of A or B is P of A plus P of B minus P of A and B. So why we have to do this? Because of this. So when you have an event A here, but there's an overlap between the event A and B. So when you are getting a number from the event A out of total, and then when you get the total number from the event B, which is, as you notice, the middle part, right? This part, right? We're adding actually the twice. We're adding by the event A probability, and then we're also adding by the event B, okay? But you cannot adding the same thing twice. So because of that, we're subtracting the one of the intersections, okay? So let's do the number 3. So find the probabilities using the data in a table. Okay, so suppose there is a study involving 300 patients. Of the 100 alcoholic patients, 87 has an elevated cholesterol level, and of the 200 non-alcoholic patients, 43 has had elevated cholesterol levels. The results are summarized in the table. So there are 300 patients, which means the total of the patient, and then of the 100 alcoholic patients. So alcoholic patient is right here, right? Which means there are 100, and then but 87 had the elevated cholesterol level. So elevated cholesterol right here, right? So we need to put the 87 right here. And also of the 200 non-alcoholic patient, which is right here, right? Non-alcoholic patient, which is 200. And then the 43 had the elevated cholesterol level. So 43 is right here. Okay, now we're going to fill it in the other blank with the other informations we have, okay? So if you add it up to the 87 plus 43, because that's the total of this two, and it becomes 130. And then the sum of 87 to whatever this is going to be 100. So difference between 100 minus 87 is 13. And then the difference between the 243 is going to be 157. And then if you add it up, this 2 will be the sum of here, or 300 subtract the 130 should be this number 2. So you should get 170. All right, so this is what we got. All right, now we are looking for find the probability, which is probability of the alcoholic with the elevated cholesterol. Okay, so the person who has an alcoholic and then the elevated cholesterol. Okay, so what I need is I'm gonna find out the kind of intersection, right? So number. Okay, let's put it this way: number of patient who are alcoholic and have elevated cholesterol. And divide by the total patient. Has been surveyed, okay? So number of the patient who has alcoholic, which is alcoholic patient, and also elevated cholesterol. So this one and this one. So it has to be the intersection, and this one to this one, right? So intersection is actually the 87. So 87 out of total of the 300. So that's all. And then you can just change the decimal, which is 0.2900. Let's round to the 2 decimal places, okay? Next one is about the P of non-alcoholic. So non-alcoholic is this is a non-alcoholic, right? This is non-alcoholic, but they didn't specify is elevated cholesterol or not with the elevated cholesterol, okay? So they just say it as a non-alcoholic. So which means the number of the patient with just a non-alcoholic over the total patient, which means surveyed. So number of the patient who are the non-alcoholic, which is 200. This is all right, because 200 out of 300. So it becomes 2/3. And then also round to the 0.6667. Then third, the probability of the alcoholic or with the elevated cholesterol. So this one used the or, right? So or, right? So which means we have to find the number of the patients of alcoholic over the total patient. Okay, let me actually make it shorter, okay? And also plus, right? We have to find the number of the patient which with the elevated cholesterol. Over the total patient. So let's look it up, okay? So number of the alcoholic, which is number of the alcoholic is this one, right? So 100 over 300 plus, and the number of the elevated cholesterol, which is this one, right? So yeah, 130, right? Out of 300. But when I look it up, number of the patients who has an alcoholic problem, right? Which means this one, right? And then number of the patient who has elevated cholesterol, and this one, right? So as you notice, the 87 is actually the overlap, right? We added the 87 twice. So we're subtracting 87 over 300, which is 143 over 300, which is that one is the answer for the probability for the as a fraction. And decimal, I got 0.4767. Okay. All right, now the next one, P, not with elevated cholesterol or an alcoholic. Okay, so in this case, we are looking for the number of the patient that is not with elevated and cholesterol over total, and or means a plus, and then the number of the patient alcoholic over total patient. And then let's see if there's a need, we gotta need to subtract one now, okay? So number of the people who has not the elevated cholesterol, which is not this one, isn't it? So 170, isn't it? So you got 170 over 300 plus, and then the number of the people who has alcoholic problems, which is this one. So 100 over 300. So I use the non-elevated cholesterol problem. I'm sorry. And the problem, and then also the alcoholic problem. So this one to this one. So as you notice that we're adding the 13 twice, right? So subtract 13 out of 300. So yeah, there's a people who has with cholesterol and then an alcohol problem, right? Okay. So and then if you do that, it's 257 over 300. So it's about 0.8567. All right, so you need to use a table to answer the questions. Okay, the next questions. Okay, so select the topping for the pizza. The probability that as a customer selects a pizza with a mushroom M or pepperoni P is a 0.55. And then the probability that the customer selects only mushroom is 0.38. And if the probability that he or she select the only pepperoni is a 0.23, find the probability of the customer selecting the both items, which is they're looking for the pepperoni and the mushroom, right? So there's a formula we have to use, okay? So formula that I introduced earlier, okay? So probability of the mushroom or pepperoni always become probably for the mushroom plus probably for the pepperoni, but you also need to subtract because there's a people who like the both, right? Okay, so I'll write the formulas, okay? So what I see is the probability that the customer pizza with the mushroom or pepperoni, right? So P of M or P is 0.55. And also people who only likes the mushroom, which is P of mushroom is 0.38. Then only the pepperoni is gonna be the 0.23. So I just plug it in. So 0.55 equal to 0.38 plus 0.23 minus we are looking for the probability that like the mushroom and the pepperoni. So whenever they order the pizza, they must have a mushroom and pepperoni. So we are looking for the probability of the mushroom and pepperoni, okay? So 0.55 equal to, it's going to be 0.61 minus P of mushroom and pepperoni. Subtract the 0.61 both sides, becomes negative 0.06, which is negative pepperoni, probability of the mushroom and pepperoni. And then I multiply by negative 1 both sides to get the positive number on both sides, which is the probability of the B. So the probability for the customer selecting the both item will be the 0.06 as a probability. Okay, that'll be all for the 4.2. Thank you for listening.